Okay, hello everybody. Welcome to this UKSTT members webinar today. And today we are discussing, or I will present an emission-free rehabilitation system for gravity sewers in dimension 100 up to dimension 300. This is a Renos P-code product, basically known as FLEXIROHR, the name of the product. A couple of issues is when you have questions regarding this system or whatever questions, there is a questions box you can use, and then later after this presentation, which will last about maybe 20 minutes, UKSTT member Richard Swan will then gather the questions and I will answer them then later on. Okay, very good. So Renos, a couple of words of our company. Renos was founded 10 years ago. It's a Finnish company specialized in trenchless technology, material sales and also project sales. And we have been working together with P-code since 2018, basically developing this system and installation equipment for it. About the system, you can see on the right the picture. You can see sort of the beef of the thing is basically that you have a corrugated pipe which is welded together and can be installed through existing manholes in the hose pipe. Okay, the overview, something about the features and benefits and environmental issues regarding this method. First of all, it's a trenchless slip lining method. And if you compare to a sort of standard normal slip lining, you normally need a trench to be able to slip line normally a PE pipe. However, this pipe is very flexible. That means that we have the possibility to install through existing manholes, 800 millimeters or 1000 millimeter manholes typically. And what we do is we weld together the pipes to form a pipe string first, and then we pull it in with a wire and a winch. And the pipe itself is a standalone pipe, either ring stiffness SN4 or SN8, which means that it will be a new pipe for 50 plus years, so at least 50 years. Connectors are available for plastic pipes and also for concrete pipes. The benefits of the system. First of all, I would say that the initial investment is quite low. So you have like, well, compared to other systems, it's quite low. And the installation process is very fast and therefore very economic also. No bypass pumping is normally required. That means that there can be installation in the live flow situation. And because the pipe is very light, it's easy to transport, easy to store, and easy to handle. And one very important issue is, of course, that the training required to master this method is quite. It's not so sort of. It doesn't take a very long time. It's very sort of 2 days normally is enough, and then you are ready to go. Regarding the environmental issues, which are basically at the moment they are sort of a big concern overall everywhere in the world. So this is a really good solution regarding to the environmental issues, because no emissions during or after installations are I mean, airborne or water emissions are there. So it's really good. And in the installation, you don't have any hazardous chemicals, so it's very safe for operators. And no toxic waste, because you can use all the pieces of the pipes, weld them together, the rest of the pipes, so there's no waste and no toxic waste. And since the pipe is light, the raw material usage is low, which means less CO2 emissions. Something about the pipe. So basically, this is a unique flexible pipe produced exclusively for Renos P-code method. So that means that, well, it's unique. You can say that there are no sort of other substitutes are available. This is DIBT certified, Deutsches Institut für Bautechnik, which is a sort of must in the German market. We have been, by the way, we have been in the German market since 2014. And now 16 countries where the products has been installed, and year-round installation is possible. That means that, well, in Finland, you know, this is like a snow and Santa Claus and all of that, so it's very cold in the winter time. Minus 10 degrees is the sort of limit. So minus degrees installation is also possible. And we have tested this. The high pressure water jetting test has been conducted by Water Research Center, up to 180 bars, in accordance with this WIS. Prior to installing the pipe, it's very important to clean the pipe thoroughly. So there, to move away everything, roots and debris and whatever, intruding connections. So this is a must that you have to sort of do beforehand. And there you can of course use very nice picot millers and cleaning chains, or then yeah, jetting units. Yeah, the high pressure water jetting was mentioned earlier. What we say about the installation or the system as a whole, we say that it's easy, fast, and efficient. And easy because, of course, what you do is you first weld the pipes together above ground, and then you have a pipe string, and then you just pull it in. And normally you don't need any bypass pumping. It's basically if you have a normal flow situation. If you have a lot of flow, then you need to do something. But in normal cases, no bypass is required. We have all the connections available, and okay, minimal 1 to 2 days training, like I mentioned earlier. It's quite fast system in a way that when you have welded the pipes together, the pulling speed of the pipe in the pulling in phase with the wire end, which is normally 8 meters per minute, so it's quite fast. You can do easily 2 or 3 installations per day, and there is no curing required. That means that when the pipe is there, it's basically ready, so you don't have to wait. And fast also in that sense that the equipment needed to install is small, fits in a van. Normally in Finland or in Germany, you have 2-man crew that is taking care of the work. Maybe three guys, but it's okay with 2 guys also. The installation risk is relatively low. In compared to CIPP, for example, it's you know, when the curing starts, you cannot stop it, but here you can stop the installation and then continue later on. And this method can also negotiate bends. So if you have 15 degrees or 30 degrees bends, so it's doable. And in the end, you get a new pipe. So that means that even in when the hose pipe is in a really bit bad condition, when you are able to pull this pipe in, then it's a new pipe for 50 years. So this is, well, it's case by case basically, and you need to have the CCTV report. CCTV and cleaning is crucial. That has to be done before installation, the normal thing with real life. Okay, let's see if I can open the video. Hopefully everybody sees this. This is a short presentation, short clip of the steps of the installation. And first it's describing the welding, how the welding is done, and then the installation. I will just run it through, maybe pausing a couple of places. Okay, I have to pause it now because it's you have a pipe cutter that trims the ends of the pipe. This is very important to get the right shape, because this is a corrugated pipe and you place the welding ring in the groove of the corrugation. So this needs to be done with proper equipment made by Picot. And the yellow one is a welding ring that you place in the groove. And the pipe is positioned in this welding rig with inserts which are sort of varies from dimension to dimension. Inside the pipe, there was a welding ball. You need a welding ball inside the pipe so that the welding bead doesn't come into the pipe, so that it's a smooth inner layer. And this is a normal, we use a Hürner welding machine. It can be whatever standard. Here we inflate the welding ball so that the welding bead doesn't come in. After the welding, you just move the pipe. The pipes are delivered in 6-meter bars. Here, my colleague Juha is attaching the pulling head where the wire is then attached during the pulling in phase. Here the pushing rod and then a 2-ton winch. So we have 2 different winches. Here is a electrical 2-ton winch, and then we have a battery operated lighter winch that you can carry to sort of distance locations or locations that where are not so accessible. The wire guide, and then we are on the other chamber now. The winch is in the other chamber. This is in the other chamber. So here we have the upper pipe guide, which is directing the pipe, or actually, which bends the pipe in the right angle before you start pulling in. And now here you can see there is the lower pipe guide in the chamber or the manhole, which directs the pipe into the host pipe. So there are 2 sort of pipe guides, upper and lower pipe guides. And this section, I believe it was like 50 meters, normal standard thing. Now, that was basically the pipe is ready in the other in the receiving chamber, and here what you do is you want to seal the end of the pipe. So here with the fast setting mortar we have sealed the end of the pipe. That's done. And normally you would do 2 or 3 installations like that per day. We can take the sort of questions then later on. I think that might be something that you want to know. But okay, the work stage is basically you have the first CCTV cleaning. This must be done. Then calibration if required. Normally, if you have a good CCTV report, you don't need calibration. But for example, in Germany, they do the calibration every time, just to make sure. Then you weld the pipes together. For example, if you have this 48 meters, then you weld together this X amount of pipes divided by 6 with this welding ring. And pulling in is with a wire and a winch. Yeah, then you seal the pipe ends. So I mentioned earlier that the installation equipment has been made by Picot, and it started in 2018 or 2019. We started to figure out how to make sort of better installation equipment to be able to go global in this business. And now it takes some time, like all the R&D work takes, and there are a couple of sort of rounds that you have to do and make better and all of that. But now it's ready. So here we have welding rig here on the left, and in the center, for example, pipe cutter, and then the upper pipe guide. These are just examples of the equipment. And basically, the whole package is available in Picot, by Picot, so it's there. And we hope to be able to show this also in Nordic Live in Petersburg then later on this year. These are quite simple and lightweight, and ergonomics has been taught a little bit also. So this is very nice installation equipment. A welding rig and the insert is the sort of maybe the most important part of that, because the pipe is unique and it needs to be sort of quite precise, the welding. So you cannot actually do it with other equipment. You need to have this proper equipment for this welding. Then, for example, the upper pipe guide. Okay, this is sort of made of aluminium and makes the sort of guides the liner through the manhole so that you don't need to dig. Truly trenchless technique. Oh, then this is a boring looking table, just to sort of show what we have. Basically, it's from one dimension 100 to 300 hose pipes. So we have a lot of different options here. And what you want to notice is that whenever we do a relining with FLEXIROHR, so you reduce one size downwards. For example, if you have a DN225 concrete pipe, then you would install in DN200 FLEXIROHR with inner layer, inner diameter 170. That means that, okay, you reduce from 225 to 170. Okay, you might think, okay, this is a lot. How can it take? What about the hydraulic capacity? But normally you would say that of course, it's a smooth new pipe, which makes the sewer water flow fast and also self-cleaning the old pipe. So normally the hydraulic capacity is enough. And okay, then the other thing that you can see here is that the lengths are either 50-meter coils in the small dimensions or the 6-meter straight bars where you weld together. And then we normally deliver in bundles, or bundles, or then C containers. And then we have connectors which are pull resistant for all of these dimensions to connect to plastic pipes. Yeah. House connections. Oh, well, you know, we have a couple of customers in Finland and also in Germany that are doing manually the house connection. That means that if you have an excavation pit like here in this area renovation project in Finland, where the water pipes were rehabilitated at the same time. So then you have a pit, and then they wanted to sort of take in the house connections, which were 150 millimeter concrete, and change them into plastic. And then the installers normally pushed manually these like 10 meters or 8 meters or 12 meters, 7 meters to the manhole in the yard. The other possibility, if you don't have a manhole in the yard, then you have to dig there. But anyways, then you can have a new plastic solution for the house connections, which is easily connectable afterwards. So a very good solution for that. Yeah, then this penultimate slide here. So social and environmental impact. So this is sort of, there is no toxic material in the process. That means that this is better health and safety. No toxic waste after installation, and the installation itself is fast, which means that, okay, you have less disruption to traffic and residents, less social costs. Minimal equipment required. That means also that the space needed in the working area is sort of small. And any nanoparticles or anything like that, there is none with the system. Okay, low weight, because every meter counts. Okay, our sort of meter weight is very, very low compared to other systems. That means that you use per meter less raw materials, and okay, that makes the transportation and handling easy. No toxic materials in the process, no emissions in the air or water during or after installation. Abrasion tests have been done with the Darmstadt rocker test, which show that the abrasion resistance is good, like polyethylene. And minimal waste, because you can use all of the material. So you can, pipe ends can be welded together. Thank you. I'm happy. So whenever you need some more information, the P-Code Solutions in UK is there for you, or then you can contact me also. That was my part.
Thank you, Sami. Yeah, I'm Richard Swan. I'm part of UKSTT. I'm also employed by Picote Solutions, and I've been lucky to attend a couple of installations when I've been over in Finland with the Renos system. So we've got a few questions that have come through. So the first one, Sammy, is what are the usual applications for this method?
Well, usual, yeah. Well, of course, first of all, this is not a pressure solution, so it's gravity sewers. We've done both stormwater and sewer drains. So, and both house connections and also main pipes. So in Finland, this is sort of maybe a little bit more used. So we might have a sort of one area where we install the main lines and also the house connection. Then of course we have customers that are using only for the house connections. So and mainly installing manually. So yeah, everything with the gravity up to 300, sometimes up to 400 millimeters, I would say.
Okay. So the next one is, what is the usual length of a typical installation?
Yeah, well, we had the video clip, and there was this sort of between one chambers. I mean, yeah, one section between two chambers. So that is normally 45 meters or 50 meters or something. But we can also do two sections at one time. So then it would be like close to 100 meters, maybe 80, 90 meters. And we have done, well, special projects. The longest has been over 220 meters in one pool. So, but that was quite special because that was inside an old water pipe, which was transferred from a water pipe to a gravity sewer. So it was a little bit special.
Okay. Another question just come in is, how does the pipe perform against sulfide attack?
Sorry, which attack? Sulfide attack.
Sulfide.
Well, this is polyethylene. So you can, I cannot remember that by heart, but basically, if you are using the polyethylene tables for the chemical resistance, so this is similar. Like I have to check that. This was sort of should be. I mean, polyethylene is relatively chemical resistant, so it should be no problem. But I have to check it. Okay. I have to check this one.
In the preparation works, the preparation slide, you mentioned calibration.
Yeah.
Can you explain that a bit further, please?
Yes. So the calibration, normally what we do is if you know that you have a 150 line and you want to reline 140 with 140 millimeter FLEXIROHR. So what you do is you cut a piece of the pipe, like 30 centimeters or something like that. Then you attach the pulling head, basically two pulling heads or one pulling head and then a rope on the other hand. And so you have a rope and a cable or the wire on the other, and then you just pull it through with the winch. And if for some reason it stops, you know that okay, we need to do something there, and then you can draw it back with the rope. So this is what we normally do. So just a piece of pipe that is pulled through the hose pipe.
Okay, thank you for that.
Was that
right?
Or understandable?
Next question will be, how many meters can you install in a typical day?
Well, like I mentioned, well, 2 or 3 installations per day would be possible. That means that usually what the crew does, they weld one day. For example, if they have 200 meters to do, so they weld one day, and then they install the next day. So that makes an average of 100 meters per day. So I would say something like that. That will be about maybe, yeah, something like that. On the bigger diameters, of course, it's a little bit slower to weld, so it might be a little bit less, but as a rule of thumb, maybe 100 meters a day.
Right, one question just come in is, how do you, are lateral cuts carried out in a similar manner to CIPP? So if you pull the pipe across a connection, how do you reinstate that connection?
Yeah, this is a restriction of this at the moment of this method, because normally if you have a connection that is coming to the pipe, so and you reline with FLEXIROHR, then you need to open it. And I mean, it's not at the moment, it's not possible to do it trenchless. So you need to open this, because you have some annular gap in between. So we have not found a good solution for that yet, but we are working on it. So this is sort of one downside of this method.
Okay. So I think the other question is a very similar one, is on the lateral connection, if there's a gap between the hose pipe and new product,
yeah,
what is the maximum length? Hang on, I can't get all the questions actually. So how do you seal the gap between the new pipe and the lateral connection?
Yeah, this is like I mentioned, this is what we are working on. We have a sort of an idea how to do it, but at the moment, because it's on a sort of development phase, so I would not sort of comment this further yet. But we know that this is sort of work in progress at the moment.
Okay, and question here, will you be at No Dig Helsinki in 2022?
Yeah, definitely. We have not sort of booked a stand yet, but we will be there.
Yeah, so that's the next question. How do you book the stand?
Okay. But yeah, it's of course it's like yeah, I don't know if it's available. Are the stands available yet? But I doubt. But of course we will be there. So it's definitely so. And hopefully also, like I mentioned, on the Pico stand in No Dig Live. This is our plan this year. I mean.
Right. How obviously when do you grout between the hose pipe and the new pipe?
We normally don't grout if it's just a sort of the normal reduction. I mean, if you have 225 concrete and then you install this 200 millimeter pipe, that means that you have 25 millimeters of annular gap. Then we don't do anything. But if you need to do it one size smaller, for example, from 300 to 200 millimeters, then you have a 10 centimeter gap. Then you need to grout. So this is the standard rule. And then we have, of course, we have an installation manual which then sort of explains how to do it. And what we do actually is a different thing. We do in Finland, we use lightweight concrete, and in Germany we use the Dämmer, this a little bit heavier stuff.
So just here, quick question is, what is the welding method? Is it butt fusion as for PE pipe, or is there a special method? And the second part of it is, and how are the joints tested?
Yeah, this is a sort of special method. I wonder if I have one welding ring here somewhere, but anyways, it's like it's a specially developed welding ring that fits into the to the corrugation, in the groove of the corrugation after cutting the pipe. So this is a special welding technique, but it's not so, I would say it's not that difficult to handle, I mean, or master this thing. So the tests, we normally, this is a visual inspection basically. What you do when you have welded it to get welded the two pipes together, then the installer checks visually how it looks and so. But normally we don't do anything else, because if the welding is bad, it will break. The welding will break during the installation. That is the fact, because it's you have to bend the pipe so much so that it's sort of. But this is very rare that it happens. And you can see it basically from outside. You can see how the welding looks, and of course inside, provided that you have the welding ball inside, which makes the inner layer smooth.
So what is a typical welding time for a 150mm joint?
150 joint. I would say that is like I would say it's like 200 seconds. So, and then you have to wait the cooling time. Normally, rule of thumb is 400 seconds. So it will be then 600 seconds, 10 minutes, the whole thing, basically. This is a little bit less actually for 150, because it's it's like under 10 minutes the whole process. So welding about 200 seconds, cooling down about 400 seconds. That is normal. Relatively fast. You easily weld over 100 meters a day. So normally, it depends a little bit, but how long a day you want to do. But and if you are using one or two welding rigs, we are using normally 2 welding rigs at the same time, because you can do the sort of the work simultaneously with 2 machines. Yep.
Okay, I think that's all the questions.
Okay. Nice questions. I will come back to this sulfite attack. I have to check this chemical resistance table. It's sort of. I will come back to this and maybe send the information to you, Richard, and then this.
Yeah, that'd be good.
Okay.
I think Alice, it's back to you. I think we've got all the questions done.
That's brilliant, thank you. I'd like to say thank you to Sammy and Richard for your time today. I hope all the attendees have enjoyed the information given, and we look forward to seeing everybody on the next webinar. Thank you for your time, and goodbye.
Thank you. Goodbye.
Thank you very much for attending.